Imagine a place where time slows down, where stars are born in colossal explosions, and where mysteries stretch beyond the limits of our imagination. Welcome to the universe, an endless expanse of wonder and mind-boggling secrets. Did you know that there are stars so massive they make our sun look tiny? Or that there's a black hole at the center of nearly every galaxy? Today, we're uncovering 10 jaw-dropping facts about space that will blow your mind and make you fall in love with the cosmos all over again. So strap in, hit that like button, and let's blast off into the most fascinating corners of the universe. We explore the awe-inspiring wonders that lie beyond our pale blue dot. Tell me why comets have tails. Comets, those celestial wanderers, have captivated humankind for millennia with their ethereal beauty and unpredictable appearances. As they draw closer to the sun, the intense heat causes the frozen surface to vaporize, forming a glowing halo known as the coma. The solar wind pushes against the coma, stretching it into a magnificent tail that can extend for millions of kilometers. Comets often sport two distinct tails, a bluish ion tail and a yellowish-white dust tail, both pointing away from the sun. Tell me why Pluto is no longer a planet. Pluto, discovered in 1930, was initially celebrated as the 9th planet in our solar system. It held this prestigious title for over 7 decades, becoming a beloved member of our cosmic family. However, in 2006, the International Astronomical Union, or IAU, reclassified Pluto as a dwarf planet, sparking widespread debate. To understand why this decision was made, we must first establish what defines a planet in the eyes of astronomers. According to the IAU, a celestial body qualifies as a planet if it meets 3 specific criteria. First, it must orbit the sun, which Pluto does. Second, it must be massive enough for its gravity to pull it into a nearly round shape, a criterion Pluto also meets. And third, it must have cleared its orbital neighborhood of other debris. Pluto meets the first 2 criteria, but stumbles on the third, as it hasn't cleared its orbit of other objects. Residing in the Kuiper Belt, a region filled with icy bodies and dwarf planets, Pluto shares its orbital neighborhood. Unlike the more massive 8 planets, Pluto hasn't cleared its path, which is a key requirement. This reclassification reflects our evolving understanding of the solar system and the complexities within it. Pluto, though now classified as a dwarf planet, remains a fascinating world with its own moons and a thin atmosphere, continuing to captivate scientists and enthusiasts alike. Tell me why the moon has phases. Gazing up at the night sky, we've all witnessed the moon's mesmerizing dance through its phases. The moon doesn't generate its own light. The glow we admire is sunlight reflected off its surface. As the moon orbits Earth, the angle of sunlight changes, giving rise to its phases. When the moon is between Earth and the sun, we see the new moon phase. As it continues its orbit, we see the waxing crescent, first quarter, waxing gibbous, and finally, the full moon. From the full moon, the illuminated portion wanes back through the waning gibbous, third quarter, and waning crescent phases. This cycle repeats every month. Tell me why the sun looks yellow. The sun, the heart of our solar system, appears yellow from Earth due to the way sunlight interacts with our atmosphere. This interaction is a fascinating process that involves the scattering of light. Sunlight is a blend of all colors, but as it enters Earth's atmosphere, it collides with gas molecules and dust particles. These collisions cause the light to scatter in different directions. This scattering effect, known as Rayleigh scattering, is why the sky appears blue. The shorter blue wavelengths scatter more than other colors. As blue light gets scattered away, the remaining colors combine to create the yellowish hue we perceive. This is why the sun looks yellow from our vantage point on Earth. During sunrise and sunset, the sun's light travels through more of the atmosphere, scattering even more blue light, and leaving the longer wavelengths like orange and red to dominate. This extended path through the atmosphere enhances the scattering effect. This creates the breathtaking hues we see at those times. The sky can transform into a canvas of vibrant colors, making sunrise and sunset truly spectacular. In space, the sun shines a brilliant white. Without an atmosphere to scatter the light, we see the sun's true color. Tell me why stars twinkle. As darkness descends, we've all gazed in wonder at the twinkling stars. The answer lies in Earth's turbulent atmosphere. Starlight, traveling vast cosmic distances, encounters pockets of air with varying temperatures and densities. This causes the light to bend and refract, creating the twinkling effect. Planets, being closer, appear as tiny disks, and their light averages out, resulting in a steadier appearance. So it's not the stars themselves that twinkle, but Earth's atmosphere adding its own touch of cosmic magic. Next time you see a twinkling star, remember it's the atmosphere at play. Tell me why black holes are invisible. Black holes, those enigmatic cosmic entities, are invisible due to their immense gravitational pull. Their gravity is so strong that not even light can escape once it crosses the event horizon. Imagine a cosmic drain, a point of no return in the fabric of spacetime. While we can't directly observe black holes, we can detect their presence through their effects on their surroundings. Matter spiraling into a black hole emits intense radiation, creating bright accretion disks. By studying these effects, astronomers can infer the presence of these invisible cosmic monsters. Tell me why Saturn has rings. Saturn, the majestic ring giant, has captivated astronomers for centuries. Its rings are composed of countless particles, primarily made of water ice, ranging from tiny grains to massive boulders. These particles are remnants of comets, asteroids, or shattered moons, torn apart by Saturn's gravity. The rings are divided into distinct bands, separated by gaps created by Saturn's moons. The most famous gap, the Cassini division, separates Saturn's two brightest rings. The particles within the rings constantly collide and interact, creating waves and patterns. Saturn's rings are a dynamic and ever-changing spectacle. Tell me why the Milky Way looks like a band. On a clear, dark night, you might witness a faint, luminous band stretching across the sky. This is the Milky Way, our galaxy, seen from within. Our solar system resides within the Milky Way's galactic disk, a vast flat structure. When we look towards the galactic center, we see a greater density of stars and gas, creating the bright, hazy band. As we shift our gaze away, we encounter fewer stars, creating the illusion of a band. Vast clouds of interstellar dust and gas obscure our view of more distant stars. The Milky Way's band-like appearance is a cosmic perspective from within our galaxy. Tell me why there are craters on the Moon. The Moon, our celestial companion, bears the scars of a tumultuous past. Its surface is pockmarked with countless craters created by space debris colliding with the Moon. Unlike Earth, the Moon lacks an atmosphere to protect it from these impacts. The energy released upon impact excavates a bowl-shaped depression, the crater. The Moon's lack of an atmosphere preserves these craters, making it a record of billions of years of cosmic bombardment. Tell me why Mars is red. Mars, the red planet, has captivated our imaginations for centuries. Its reddish appearance is due to the presence of iron oxide, or rust, on its surface. Billions of years ago, Mars likely had a thicker atmosphere and liquid water, allowing iron to oxidize. This rust-colored dust spread across the planet, carried by winds and storms. Mars' rusty soil holds clues to its past habitability, potentially preserving evidence of ancient life. Thanks for joining me on this cosmic adventure, fellow explorers. We've journeyed through the cosmos, unraveling the mysteries behind comets' tails, Pluto's demotion, the Moon's phases, and the Sun's golden glow. We've peered into the depths of black holes, marveled at Saturn's rings, and traced the Milky Way's band across the sky. But our exploration of the universe has just begun. Keep looking up at the stars, keep asking questions, and never stop exploring the vast and awe-inspiring cosmos. If you enjoyed this journey, don't forget to like, share, and subscribe for more fascinating insights into the universe. Leave a comment with your space questions. We might feature them in our next video.